I'm going to plow on then, and we'll go with that. So, right, I'll start again for those that have just joined. So thank you for joining me. I'm going to try and have my first attempt at some live streaming today. My name's Steve. I'm a .NET dev. I work for Elastic. I've just joined them in November, working on the Elasticsearch.net client. So I'll be focusing on this stream on some stuff that I'm thinking about for the client, and then hopefully in future streams we can do some more stuff around using Elasticsearch.net as well. So I'll just share my screen here, and I've kind of set a few goals for this session. I'm limited to about an hour. So the scenario that I'm looking at really is that I would like to do some analysis around benchmarking of deserializing JSON. So the context for this is that in Elasticsearch.net, obviously, we're communicating with a REST API, which is how Elasticsearch.net kind of exposes all of its functionality, and the client is communicating with that. And what we're doing within the client is we're then taking the return JSON responses and turning them into strong types that you can work with in the client. And there's a history of how that serialization has worked. So some of it was previously using Newtonsoft JSON. The core now of the project uses Utf-8 Jason, which is done for performance. And we've also got some stuff that's configured using system.text.json, which is kind of Microsoft's new high-performance serializer. And what I'm interested in is, can I generate code in the future, at least, that might be more efficient for taking the JSON and turning it into a type. So obviously things like system.text.json are meant to be highly optimized, but there's a limit to how optimized they can be because they don't fully understand our types, so they've got to be able to kind of deal with whatever JSON comes at them. So I'm going to hopefully, towards the end of this stream at least, we'll maybe start playing around with creating our own reader based on system.text.json, and then we'll see if does that have less allocations and does it perform better. But in order to do that, what we need is a project that we're going to use to test all of this stuff. So that's the goal. We're going to create a project that we're going to use for benchmarking. We'll set up benchmarking in there. If we get that far, we'll create a custom reader and start comparing that against those sort of default deserialized methods on things like system.text.json and Utf-8 Jason. And as I say, the end goal of this stuff is that eventually we might get to a position where in a future version of Elasticsearch.net, we'll be able to generate the requests and responses based on sort of a schema that we're working on, so that we don't have to do so much manual coding for the types that we need to do the strong typing. And if we can get that far, can we then use something like source generators or just another piece of code gen tech to generate efficient classes for turning that into JSON and back from JSON when we get it back in as well. So I'm going to kind of kick off. So I've got an empty folder that I'm going to be working in. I'm going to open up a Windows terminal here. Let's hopefully make that big enough. So what I'm going to do initially, I'm going to do a few things from the command line just because it keeps me fresh and it's been a while since I've done this. So let's call this JSON benchmark. So we're going to create a folder under here. We'll enter there, and then I'm going to do a .NET new solution. I think it's that. Yes, so that's going to create a solution in there. Yes, which is just an empty solution file. And then I should be able to do .NET new. So we're going to do this in a console app for the benchmarks, and then I'll probably put in a test project as well, so that we can compare the versions that we're making, make sure that they are actually deserializing correctly. And so I'm going to put this in a source folder. I kind of tend to like having a source folder for where my actual projects live. So let's give that the same name. I think that's the right command. Okay, so that's created an empty project, console project under source/benchmarks. And then I believe it's .NET solution. I remember the command, probably add. Yeah. Add. Is there help for that? So solution folders where we are. So I think I can just do dot source, oops, and then that's my folder, and that should add the project. So let's just double check what we've got here. So we've got a folder where we're going to do the solution. In there we have a source folder and a JSON benchmarks project. Could create the test project now, I guess. Yeah, let's do that. So if we have a look at .NET News command line here, let's see if the help gives it here. I'm pretty sure we can do XUnit directly from here. Maybe it's that one, isn't it? I think. There we go. So you can see a whole chunk of projects types that we can do, and yes, XUnit unit test project is one that we can create. So we may as well do this as well. So let's create this as a XUnit project, and the output for this can be test slash JSON benchmarks. I'll call it tests. I prefer tests. Like that, and we can then just add the tests project to that, and then we start this up in Visual Studio, because that's about as much as I want to do in the command line at the moment. Bring this over here. So while that's kind of loading itself up, if you have any questions, I'm going to try and keep an eye on the chat over on the other monitor here. So if you have any questions as I'm going along, do shout them out. I want to try and keep this interactive, and hopefully, you know, we can learn together, because you'll probably throw questions at me that maybe I can't answer directly. So, okay, perfect. We have a solution. We have our tests project, and we have our kind of console project here. The other thing I'm going to do is configure Git for this. We won't need it immediately. Come on, Visual Studio. This is a complete test of the power of this older Dell desktop that I'm on, so I'm hoping it can kind of keep up with one instance of Visual Studio and streaming directly, but if it can't, I have a plan B for the future. So I thought I could set repository settings. I think I can set in here. Okay, perhaps I have to git init first before that all works. So if I do a git init on this directory, what I'm hoping, I suspect I'm going to have to reopen this. So if you haven't seen this before, this is kind of the new Visual Studio 2019 Git integration. That's interesting. So that's the Git global settings. Okay. Well, what I was going to do is I was pretty sure that this should allow me to basically add a git ignore and a kind of standard file format for Visual Studio, but I'm not seeing that at all. Let's just do one belt and braces check, and let's just reload the studio on here. If this doesn't work, I'll just copy some over from another project. I have done this not that long ago, so I assumed it was going to work, but let's see. Aha, okay. Visual Studio's now picked it up. So this is what I wanted. I want to add a git ignore, git attributes, and this will just add the standard ones that we want. So hopefully now we should see in the root of this folder we got those. So we've got our project structure. We've set it up for kind of standard git ignore and all of that kind of stuff. So let's just check our status here. Yeah, so I'm just going to add everything. Do a commit here. Make this our initial commit. And I realize now that this can't be seen on the screen. So I'll clear the screen because that's not showing for you. And there we can see this is the command that I just ran. So I basically did a git status, which had some files that were needed to be committed. I added them, I committed them, if you didn't see that on the screen. So I'll try and remember to keep this, in fact, let's minimize this a little. And we can hopefully never drop that off the bottom of the display there. Right, so where are we at? So we've got solution structure that we wanted. So the first thing I'm going to do, I think, is let's add some NuGet packages. So let's start by adding, I think we're going to test, even though we're not really using it today, I'm going to test Utf-8 Jason, which is the first one in the list, in fact. So we'll add that just kind of as a comparison and kind of a baseline. It'll be interesting to see why we might want to use a different library for this kind of stuff in high performance situations. It's also worth noting as well, the stuff that I'm doing or will be doing where we're kind of benchmarking this stuff and we're looking at kind of high level custom readers to be sort of highly performant. That's not stuff that you might be doing in your day-to-day projects. But this being, the intent of this is to go into the Elasticsearch.net libraries and nest, and of course those are things that are going to be used by many sort of thousands of other applications. So we want those to kind of give you performance for free out of the box, so that you don't have to worry about this kind of stuff. So we're going to use Utf-8 Jason as well, and the final thing then I'm going to want is benchmark.net in here as well. So this is basically going to be my benchmarking project. Could do all of this via the command line as well, but I think it's just quicker to get going that way. So if I open up the project file now for this, and just see what's happened. So we're targeting .NET 5 here. We're using benchmark.net. We're using Utf-8 Jason and Utf-8 Jason. So the first thing I'm going to do is in here in my program class is let's add our kind of our first kind of test scenario. So we'll come back to, actually we could do this, we could be fancy, and we could try and use top level programs for this. Get rid of this and we'll see if we can do this in a minute. So let's just create a class which will be our JSON benchmarks, which is harder to type than you'd think. We'll create a class JSON benchmarks. In a minute we'll be filling this up with some stuff. And then what we're going to want is the benchmark runner from benchmark.net. And one of the easiest ways we can get this to run some benchmarks is just point it at a class that's going to contain them. And that should be fine. So this is kind of a top level program format, which means we don't need program main, and we don't need all of the classes and the methods that you'd normally see in this kind of program class now. The C# compiler and C# 9 will convert this behind the scenes into a program main method, but we just don't need the boilerplate there. So that should be our runner configured. I know I'm going to want to do memory diagnoser on here. So this is an attribute that we can add to a class that says when benchmark.net runs this, also take memory information for us. I'm just going to hop over to another window, just check if there's any other comments coming in. Nothing at the minute. Okay, so we're going to need a couple of things. So I've already prepared ahead of time. I've been thinking about a good class to test on, so I'm just going to drag over a VS Code window here. So this is the Elasticsearch.net library, and this is an example of what a response class looks like. So you can see this has all of the properties that map to parts of the JSON that we're expecting to come back for when someone does a cluster health request. And so I think this will be quite a good kind of sample class. So I'm going to bring this in into my app over here. We're going to need some types, so we'll let them resolve. So I'm going to do a couple of things. So I'm not going to worry about this slightly more complex scenario of indices at the moment and dictionary, because that uses a custom serializer at the moment, or custom resolver, and I don't really want to have to kind of fake that all up. Okay, yeah, I'm going to zoom in a bit on the code. So let's comment from Blazer Mr. Magoo, which is a great name. So hopefully that's a little clearer now. So I'm going to get rid of the response base. We do have a kind of a hierarchy to the types, but just for this test, let's focus on this class. And then the only other thing here is we've got health, which I think is an enum. So if I come into here, yes, it is. So let's make sure we drag this over as well. Now it's got a couple of attributes on this that I think live inside Elasticsearch.net, which control how this gets serialized. For the time being, I'm just going to get rid of that and see how we go. So we might have to do some stuff with that. So we've got a class. So the other thing that we can do, or we should do then, is have a look at what the code looks like. So if I get let's get this up on another screen, customer health response, Elasticsearch, and hopefully zoom this in a bit. So this is the cluster health API. This is what behind the scenes the client's actually communicating with. There's a lot of information in here, but I'm hoping, yes, we do have a sample of a JSON response from there. So that's going to save me faking this up. So I'm going to use that. And let's do a little bit of stuff on this. So I'm going to put this in a string literal into the code. So I'm just going to do a lazy find and replace here. So I've done this recently. So yeah, I'm going to replace all the single double quotes here with double quotes. And that should be enough to make this something I can paste in. So in the benchmarks, I'm going to need a string for our data. So let's have a private const string. Let's just call this JSON response. And we'll make this a literal string. And if I paste into here, my code, that's kind of worked where we're at here. So that's the end of the JSON and the semicolon after that. Cool. So now we have the text version of what a response would look like. Realistically, we're going to be working with streams. So coming back from some HTTP client, when we make the request, we're going to get back the response stream, and that's what we'll be reading from. So I'm going to kind of need to simulate that, I think, a little bit. So what's the easiest way of doing this? We'll create a private stream. We'll just have a field on here for the stream, and then I think what I'm going to do is set this up as part of benchmarks.net's global setup. So there's a method or an attribute here we can add to a method, and I'm just going to create a setup method. And what we want to do is basically set this stream up. So this will run once as part of the benchmarking process. It won't run before every iteration, but it will be kind of the first thing that we're doing. So I'm going to do a memory stream should do us here. So this isn't 100% going to replicate bytes actually streaming in over the wire from HTTP client, which might, in theory, in a big request, take a moment or two. But what we can at least do is we're just really testing the serialization piece, and we'll make assumptions that we haven't always got the whole stream when we do our kind of custom thing. So I'm going to get the bytes for this from our JSON string, JSON response. So that should be all we need. So now we're going to have a stream which contains the Utf-8 version of this, the bytes from this, when we're doing our test. So that's as a really simple belt and braces check. Let's create a method here. I was going to make it asynchronous, but I don't think Newtonsoft JSON gives us that. So let's call this Newtonsoft JSON. So this is going to be one of our benchmarks. So let's make this a benchmark. And all we do inside the benchmark method is execute the code that we're actually interested in kind of testing out, I guess. So by that I mean, what is it we actually want to measure? And the benchmark runner and the way benchmark.net works is it's going to run each of these benchmarks in their own kind of isolated process for us. So that's kind of cool. So I'm going to need to do, I'm going to need to read from the stream. Actually, I totally forget that there's probably a documentation around this. We can just save some time. So Newtonsoft JSON stream. I think we just get a stream reader and pass that in. It's in here, but I know there's a code sample, and when you can copy and paste, let's do it. So this is basically what we want. Don't need the actual thing. So let's grab this, bring these in. Visual Studio is going to kindly hint that we can use the using declarations for these, which I prefer. This will be the actual stream. What are we unhappy with here? Can I because Utf-8 Jason reader? Oh, is this picking up? Yeah, it's picking up a different namespace. So because we're gonna have a few types in here. Let's see if we can find it. I think that should make that happy. So we're gonna have a few different like conflicts here because let's see, JSON Serializer. Oh, that is already picking up the right type, right? No. Let's get rid of this for the time being because we're not going to do Utf-8 Jason. That'll save me some trouble for now. We will kind of fight these again in a moment, but let's deal with this. So what we're doing is we're reading from the stream. Now, a gotcha here is this is going to run many times as part of a test. So one of the things I'm going to do is because it's a memory stream, I can just actually I can just do stream.position as part of the start of my test. So I want to make sure I'm always reading from the start of this stream because it's going to bug me. I'm going to change these to var. This can be var as well. That's just a personal preference. So we've got that, and then what I'm going to do is just to make sure that the response actually gets kind of put somewhere useful. Let's have an instance of this, which is going to be cluster health response. So we're going to have a field that's going to hold the actual response, which we'll set using the deserializer, which should convert it to that type. Okay, so that, if I'm correct, should read from the stream, should deserialize to this instance, and then our benchmarks will be measuring that. Now this is where the test might be useful, because at the moment I'm just making assumptions that this code works. And I think, just to save myself some time right now, I'm just going to actually execute this code in debug. So I'm just going to create an instance of my benchmark class. What did I call it? This is it. So we get a new instance of our class, and then b.newtonsoft.json should call the method. So we're just making sure at this stage that I'm vaguely sane, and this actually compiles and gives us an instance of cluster health response. Yeah. So I'm going to need to set up. I'm going to need to call setup. So this is obviously stuff that would be done by the benchmark runner for us, but I'm going to need to call that. And I'm fairly sure now that I think about it that this is not going to work. But let's prove the point. Yeah, okay, it works. It's always surprising. So you can see here we've got the actual response. That might be a bit fuzzy again on smaller screens. But we've got, we picked up the cluster name, we picked up the active number of shards. So as I say, I think in a moment what I'm going to do is write a test around this so that I can actually validate that all of our serializers can actually get this this data type. And I think as part of that, it's probably sensible in a moment that I go through. Let's think about the best way of doing this. Probably want to give different values to each of these these here, so I might as well start doing that now. So when I run a test in a minute, it might make good sense to make sure that everything deserializes. Each property is deserialized as I'm expecting. Let's give that 100. That's 50. That's fine. So that's different enough, I think. So in theory, this compiles, this runs. I'm going to get rid of this temporary code. I'm going to enable that code there. Let's do it through Visual Studio. So I'm going to set to release. Benchmarks have to be run in release mode. And what we're going to do is Shift F5 on this project now to kick off the benchmark. So ideally, when you're running benchmarks, you wanted to do this with as little else running as possible. Okay, so that's immediately failed. Cannot access closed stream. Okay. So what's happened is the first benchmark warm-up phase has run, but I think on here I can set leave open true. So what I want the stream reader to do when it's disposed at the end of this method is not kill this stream that we've set up in our setup, so that the next time this is called, it's going to be still available for us, which is why we're repositioning to 0. So benchmark.net by default is going to do a warm-up phase where it's going to run this code a few times to JIT it. It's going to do some measurements about how many iterations of the test it's going to run, and it's going to run multiple iterations of the test as well. So the reason it does that is to get good statistical averages across the test. If you run this code once and you take a measurement of how long it takes to execute, there's all sorts of things like virus scanners and other processes that are running that could affect that. So it's going to run maybe hundreds of thousands even of iterations of the code to give a good kind of statistical average and take the data that we need. So I'm going to try and kick this off again, and then I'll just see what's going on in the chat. So hopefully this is now running. Let's just make sure it gets past the first phase. Perfect. So here we are. We've done the overhead jitting. It's now piloting. It's warming up the code now. So this is making sure that things like tiered compilation don't affect our results too much, and we're actually working with code that's kind of warm. And now it's actually running the tests. So let's have a look at what's going on in the chat while that's running. So, hi John. I know John Calloway. So good morning, John. Question. So this is from A. Lacard. I'm going to be terrible at reading people's usernames. I'm going to go with that for now. Wouldn't release likely to optimize out setting the cluster health response as private field with no references. It shouldn't do in the case of the benchmarks, because the benchmarks are looking to set that field, or the code setting that field. The reason we run in release is we do want to be running this code kind of as close to real as possible. And so when this is running in production, of course, we'd be in release, and that will do a number of optimizations and things on the code. And we want to make sure that those are applied in our kind of benchmarking world. I believe what I've done there is valid. So I think this would work even if we didn't set a field and we just kind of set it as a local variable. It should still work, but I like to kind of set a field on the class anyway. Because behind the scenes, benchmark.net is going to kick off a process that contains this class and this method and kind of execute the code for us. So it's run. See how valid we are at the moment. So it's saying it's taken around 8 microseconds there, and we're at 6.23 kilobytes allocated. So moderately high given what we're doing, which is just creating a type based on that JSON that we're coming in. So I guess the next thing to do would be, let's compare this with where we're kind of at today, which is Utf-8 Jason. So I'm going to create a new benchmark for that. Utf-8 Jason. This is where we're going to run into all sorts of type conflicts, I suspect. Now this should be a bit simpler, because I don't think we have to. I think it basically, JSON.net doesn't really just take a stream, but I think Utf-8 Jason does. So we can see that if I do Utf-8 Jason, actually, make even worse for myself if I have my own types with these names conflicting as well. So let's give it a fighting chance. JSON Serializer dot deserialize. Now this could be interesting. It does offer a synchronous version of its APIs, but realistically, I want to test this against async because that's what I'd be using in the production code. Utf-8 Jason, I don't think has an async API. Yeah, doesn't any at the moment anyway. It would be nice to be like for like. The difference being that in a moment I'm going to make this. Well, to do this, I'm going to need to make this method async task returning. Generic task. I'm going to make this task returning because we're going to await this. And so there's a little bit of extra overhead there in terms of there's a state machine involved and things like that. So we'll just kind of ignore the differences because this isn't the main comparison I want to do for the time being. So we want to deserialize into that. We want to pass in the stream. I think is that all I need? Yep. I must remember to set the stream position on here as well so that when this runs it's going to be correct. I think that's all we need for our Utf-8 Jason benchmark. Let's be brave and just test that entirely. So okay, again, Control F5 on that to build this. Yeah, so that is a good question about how those private fields are optimized or not optimized. I'm not entirely sure. I'm pretty sure benchmark.net's kind of clever enough to keep references around to the stuff it needs to in order for those tests to run. And it's definitely measured something. The main thing I really care about is the measurement of creating an instance of the type. As long as that's captured by the benchmarking of the memory allocations, that's kind of all I'm after for this process. So this will be a little boring if you're watching the stream because we're going to run this a couple of times. So it's run the Utf-8 Jason and now onto the Utf-8 Jason. So it's not taking too long. You can see, we are doing quite a lot of operations. 200. So it's decided 262,000 runs is sufficient. So it's executing that code often as we're going through it. Can increase the screen size of that a little. What I might do is switch to using the console for this in a moment because I think it'll be easier to see in the actual other console. Just going to let that run. As I say, at this stage, Utf-8 Jason is kind of out of the picture, but it's just a kind of comparison to see what gains we've kind of got in the library already just by having Utf-8 Jason in the code. So you can see, yeah, that's considerably quicker and far less allocations. And this is kind of what we care about in this. Well, we care about both, to be fair. As I say, as this is a library that other people are going to be consuming, if we can avoid delays and we can avoid allocations in your applications, it's going to make your stuff run better if you're consuming the library. So this is kind of the end goal, really, is to see, can we get this down? And that's not bad. There's obviously some cost there of the type. So we're basically creating an instance of that cluster health response. There's definitely a string in there, so there's a string allocation that's going to be on the heap. These are heap allocations. There's some overhead, clearly, because I think that's larger than the size of the object that we're dealing with, but we can prove that shortly. So the next test is let's compare to system text JSON, and then I think we're going to have to put in some tests because after that I'm going to be doing some fairly horrendous looking code, I suspect. I have played around with the type of code I was thinking about in the past. So I'll sort of have a little bit of it in my memory, so don't assume that all of this is stuff that I've just got off the top of my head. Some of it is coming from my own memory. So okay, well, that works. Okay, so system text JSON is built into into .NET, so it's part of the libraries, and we're using .NET 5 in this benchmark project. So this is just available. I haven't actually referenced this specifically because we're targeting .NET 5. We get all of the kind of common libraries. Yes. So Blazor, Mr. Magoo. Yes, we're going to test it now. So we're going to test system text JSON. So this is the in the box stuff. This was added .NET. I want to say 2.1 or 3. I can't remember exactly when it came out. It's kind of grown. It's been missing a few features over time. I think it's a bit more feature rich now, so it can do like deserialization into private fields, that kind of stuff, which we may rely on quite heavily. I'm gonna test this because I am 90% sure system text JSON does not work with these data member attributes. I know they have their own attribute type. Let's, again, probably should have just unit tests for this, but let's just kind of do this in a hacky way again. Oops. Let's make this system text JSON mark. This is awaitable now. You notice these top level programs, what's quite cool is we don't have to mess around with the main method and change its signature. This just knows how to deal with, whether this needs to be async or not. So we're going to run that. We're going to come to this point. I'm going to flip back to debug, run the code. Okay, well, it didn't blow up, but it did not serialize as we hoped. So trying to remember the attribute, I'm going to have to search for this JSON. JSON name. JSON property name, system text JSON. That sounds like what we want. So that's just going to take this, I presume. Okay. Let's add this to this one as well for now. And restart the app. And then let's just see if we at least get these two properties deserialized this time. No. It's interesting. I wonder if I need an attribute on the type as well. Let's see if I can think about this. Feels like that should work. It's definitely not set in cluster name. I don't know how it deals with the enum either. So, first problem. Why is that not working? We're setting the type, we're using the serializer, deserializing into this with the stream. We've given it the JSON property name. I'm just going to stop this. Okay, I see the problem. This is a good old problem. So at the moment, these response types use internal setters, and I'm pretty sure system text JSON doesn't like those yet, or if it does, there's something else I have to do. Well, let's just do these first few and benchmark, run this again. Yeah, okay, so now we're getting test cluster through on the cluster name, so that's working. So just a little bit of boring work now to chuck these on. Just going to chuck the attribute on and then go through and put the right strings in. There's probably all sorts of shortcuts and clever tricks to do this kind of stuff. I've certainly seen people with some supreme text editing skills inside Visual Studio Code, where you can kind of maybe take some of these repetitive actions out of the way. But for the sake of this small class, I'm just gonna do this by hand. I'm not sure how well we handle these enums, and if there's default enum support. Actually, I've got a feeling there's a setting for that in options that I've seen. So we might need an instance of the options. Okay. Let's see. So at the moment, what's in the actual code? So we're expecting status yellow on that enum, and I'm thinking we're going to get the default still, which is green, which is true. So we're going to need an options of our options equals new JSON Serializer options. That one. And then I think something called enum. What would it be called? So players and Mr. McGee is suggesting maybe JSON include attribute would work for this. Is this for the enums? I'm not familiar. Or I've not done it enough to know. Might have to resort to, yeah, that was the private setters. Okay, yeah, so we can have a look at that in a moment. Let's have Google. So system.text.json. Oh, I have searched this in my history. How to serialize JSON string enum converter. This sounds kind of what we want, maybe. It's one of those things where you can see your old views on stuff and you know you've looked at this in the past and you try and remember. Serialize enums as strings. Yeah, okay. This is what we want, isn't it? So it's the joys of you don't use this stuff often enough. So I think that might just work. So we can pass these options in. Now this is now a question for me in my benchmarking. Like, there's overhead to creating this, and we'd be measuring the allocations of that in this test. Now realistically, if I was putting this into real code, what I would do is have an instance of this, just kind of static instance on the class probably, which I think I'm going to do here because I think that's fair. So let's just have a read-only JSON serializer options. And paste that in there. And we obviously need to give it a name, so I don't annoy myself. So this is cool. We can get rid of this because we can use these target type new expressions in C#9. So because we know the type here, we don't need the type here. I kind of like it. I haven't fully decided if I'm going to use it everywhere, but I kind of like it. So we've got an instance of this. This could actually be static as well. So let's pass that in. So this is kind of, there is extra overhead, but we only incur that overhead once in a real application, so I'm not really going to measure it in my benchmarks. I'm kind of keen just to see how this performs. So let's do one last check and see if this actually serializes properly, and then if it does, as I say, we should have checks around this. Green, that's not what we want. I don't think that's right. So let me go through. I've got another app that I can maybe refer to because I know I've done this somewhere in a previous lifetime. Static for now. Just let this be created once per benchmarking class, which again isn't a problem. JSON string enum converter, is it camel case? think it should be. It should work. So I've got Martin on here as well, my colleague at Elastic. So this will be interesting for him, I hope. Yeah, any good suggestions why that's not working? Because that's kind of key to this test, I guess. So I don't know if I need to add any attributes to this. Where's the... So we've got the options, we've passed them in our serializer. I assume it works on deserializing. Yeah, deserialize. It looks like it should work to me. We're expecting it to be yellow. Did I? No, we have got that. Okay. I half did this work earlier and then kind of forgot about it. So we've still got these internal setters here, like an idiot. So let's get rid of all of these. So yeah, always a good tip if you are doing something like this where you're modifying a file, do one thing at a time and do it all the way through so you don't get halfway through and forget about it. So let's keep our fingers crossed this time. We have a cluster health response. We do have some values. These are looking more promising, and we have the enum value, which is the key thing. So I think that's working, which I'm kind of pleased about. And in fact, we'll get rid of this and let this run. But what I'm going to do is I'm going to run this over here in this code. So let's cd into source/JSON benchmarks. And then inside here we'll do a .NET run. We want it to be in release mode, and that should be all I need to do. I'm going to do this now in my in my Windows terminal, just so that I've got bigger text, so everyone can see it, and it just means we can kind of get on with other stuff as well. So that's coming along. So like it has mentioned, release mode first. So because I'm running this from the command line, I'm going to specify in the command that I'm running that I want it to be in release mode. I don't need to mess around with the setting in Visual Studio anymore, which is kind of nice. So that's kind of good. I think it's probably a good point while that's running to actually do what I keep saying I'm going to do and create some unit tests. I'm just going to make this this unit test file. Now we're getting close to the hour. I can't believe how quick the hour's going. I'd hope to be into custom serializer territory by now, but I think let's see how far we get. I do have a bit of a hard stop because I do have as is the world of COVID these days, I have a click and collect supermarket shop to go and pick up. So I need to do that, otherwise we won't eat this week. So let's do soft JSON test. Let's just very quickly validate this. So let's add a project reference to this. To the JSON for benchmarks. So what I'm just going to do is just some tests, basically running the code that I keep running manually. Rather than doing that, it makes much more sense when we have a unit test of this. So my subject under test is my new what is it? JSON benchmarks class. Is that the right one? That is JSON benchmarks. Okay, I'm going to have a namespace conflict here. New JSON benchmarks, and then we can just do sub.units of JSON benchmark. That's not asynchronous, so I can just call it like that. In fact, let's change this code a little bit. So let's actually make this a property, so that we can actually get it back off of the type afterwards. And a private setter on this. I need to give it a name, don't I? Can I do that up? So yeah, that's fine. But it will be here because we're going to set it from these. So the reason I'm doing this is when we're doing our testing, obviously we need to be able to access this class that we're deserializing into so that we can actually test it worked. Meanwhile, benchmarks are still running. So we have our test now. So then what I should be able to do is suts.clusterhealthresponse. I'm going to need another library because I really want to use fluent assertions, which I prefer. So let's add a NuGet package here. Fluent assertions. This just gives us a nice kind of actually it's not a pre-release of this. It's not totally going mad. This gives us the ability to do some nice kind of fluent now, did that actually install? I suspect not, because it didn't compile. Now it's unhappy. Where's that error coming from? Just rebuild this because I'm not convinced there is an error there. Okay, I'll kind of ignore that for now. Let's just see if I can actually get the fluent assertions to stall. Backwards project name. Interesting. Something I'm clearly missing here. So I'll just catch up with the chat as well. So Mr. Galski, hi there. What are you doing? What are we coding? At the moment, we're just doing some kind of low-level benchmarking of different JSON serializers in .NET just to compare allocations and execution times so that we can see, well, eventually the goal is to get towards building our own custom reader. And then what we'll do for that is see if we can actually get better than the kind of built-in stuff towards a goal of putting this into a future version of maybe the Elasticsearch.NET library. So that's where we're trying to get to at the moment. I just want to kind of prove what the current serializers do and also make my code compile. So I'm missing something obvious. I've got a naming conflict in here somewhere. That shouldn't conflict with anything. The namespace is correct. I'm not seeing it. Let's have a look in here what we've actually got. What's this? It's these silly little things that sort of stop you at the end of a long day coding. I mean, I know it doesn't like this. It might just be that I've called this. Oh, I've called the project JSON benchmarks, which may not be helping us here, might it? Let's rename all of this because I should really want it to call this test when I created it earlier. That's going to make that namespace happier. That might be a little unhappy. Let's just build this. I don't know. I'm going to force this reloading on Visual Studio here as well. Okay, let's try and add our NuGet package reference again. The reason this is problematic is I've got so many things now that kind of have the same namespace name or names in the types, so in the members. So there we go, we're in, we're happy. Got over that. So I'm going to jump around a bit, but let's see if we have some results here while we're waiting. Okay, so system text JSON. This is the interesting one. So this is the built-in Microsoft Serializer now. And you can see it's a bit slower than Utf-8 Jason. So from a performance perspective, if we were looking for raw speed, Utf-8 Jason is currently winning the battle here. But the allocated bytes are considerably better, and I suspect now we're getting much closer to little or no overhead. We could probably figure out how many. Well, we could probably profile this to see how much memory we actually need for our type and our strings, or we could probably figure it out, but I'm not going to waste the few minutes I have left on the stream doing that today. Let's see if we can get the tests in, and I think that might be where we leave it today. And then, as I say, I was hoping to get a bit further, but what we can do is I'll see if I've got some time this week to kind of continue this, and we can actually get into the custom serializer stuff, which would be kind of the more fun stuff, I think. So let's just do an assertion on the actual object that should not be null, first thing. And then I'm probably going to want to pull this out over to another window for a moment. I'm used to working on two screens, so you can't see it, but I've just basically pulled up my JSON so I can see all of the weird values I gave the JSON. And then what we can do, for example, is we can say the cluster name should be .b test cluster. We know that the enum serialization was problematic, so we should probably check that status enum should be, and then the expected value is what's it called? It's health, isn't it? Health dot yellow. I mean, we should probably add these in for all of the values. So timed out should be false. And what I've realized is I'm going to want to redo this over and over again on all my tests. I'm actually going to just make a private method for this, which is just going to be cert response, which is going to take in a cluster health response. I'm going to call it cert, just so I rename a bunch of stuff for a moment. So that, in fact, yeah, we can sim this down, because what we're going to say is I'm going to pass in the actual instance, so that simplifies those a little. So I'm going to rename this so I don't forget what that is. Response, and then we can just do a cert response here with cert.cluster health response. And that's going to be a bit cleaner when we come to reuse this over time. So let's do response dot number of nodes. Should, again, I'm just comparing this against the test JSON that I've kind of created for this, so it's not too exciting. But we're going to follow my own advice from earlier, and I'm going to persist with getting this in so that I know I have a test suite that will test everything is 100% deserializing correctly before we proceed with creating a custom reader, because at that point we could make all manner of problems for ourselves in terms of, you know, not properly deserializing, or deserializing and we think we've got it right, but actually, you know, we've put one of these fields in the wrong place, one of these properties in the wrong place. So I want to kind of avoid that and make sure I'm actually trusting the code I'm writing later on, because I know it's going to get a little interesting when we start doing a custom reader. The idea of this custom reader is that we'll use we'll use System Text Jason's Utf-8 Jason reader that they provide, and see how well it works. I'd like to use the inbox stuff if I can, because at the moment in Elasticsearch.net we basically ship Utf-8 Jason within the code, within our code, so that we don't actually have to have a NuGet dependency on it, and we can control the version that's going on. So we kind of specially namespace it and put it into our own code base, which is good from the point of view of we can kind of number of waiting tasks, milliseconds should be 100. Is that kind of approach is good in that we have full control over the version that's being used, but it's not so good in the sense that we have to kind of keep shipping that. And if we can move to a built-in thing, I think we'd be much happier. But obviously we need to have the suitable performance. So let's have a look. I've just realized, checking the own screen, the cameras, see if that's any better. Yeah, you can kind of see me better there. I'm just watching the video, it's just got a delay on it. Cool, I think that's our test. So let's run this and then just validate that we've got a null reference. What have I not done? Sut.setup. So this again is the setup code that's creating the stream that we're then using in these test methods. So I need to kind of simulate the call to the global setup would do for us in the actual benchmarks here, which is why that failed. Hey, green tests, that's always good. So let's copy this, make a Utf-8 Jason test. This one can use our Utf-8 Jason benchmark, which is async. So I should probably have called this async on the method name, which I would do if that was a kind of public API. There's still some debate on whether we really need that these days, but the compiler there showed me that it was an async and that I needed the await, but it's so easy for that not to be the case. Especially if you're doing editing in something like VS Code and stuff. I don't know if they've got full support for that yet. Right, so that's our 3 tests, which test all of our methods. So this will be a good proof that what we've been benchmarking has actually been fair, in that if these don't all pass, what did I debug that? That's not what I want to do. I want to run all of these. Perfect, green tests. So we got, let's recap, because I'm gonna, as I say, have to go and do a shop in a minute. Right, I've got Speed Sun. Hey Steve, do you want a rainbow green? I've got no idea what that means. Is this a Twitch thing? Is this a Twitch thing where I'm first time streaming and I've got no idea what I'm doing? It's cool. I don't know what it is, but it's cool. So yeah, sorry, I don't know what that is. Okay, so let's recap and close up the stream, and then we'll kind of come back to this maybe later this week if I can get a schedule in my slots to do it. I've got a few meetings and things tomorrow I know of, but let's see if we can do this. So we've basically at this state, I'm going to get rid of some of these weird using directives as well. We've basically got a set of benchmarks that run Newtonsoft JSON, Utf-8 Jason, System Text JSON. What we're benchmarking in these are what the cost of deserializing from that JSON body that we've converted to a stream of bytes to represent what would be coming over the wire from HTTP client. We're measuring what's the overhead really of this deserialization process to create an instance of cluster health response, which is our class here. This kind of represents, this is our strongly typed version of the response that gets at the moment is included in Elasticsearch.net, or I should say into the Nest library of Elasticsearch, so the higher level library. This represents that type, and at the moment crafting this is kind of a little bit of manual work. Future plan is that we can generate these types from a specification, which would be good, and then my overall objective is can we make the deserializing then of these auto code generated types? Could we write code to deserialize them more efficiently as well? So we've got our 3 benchmark methods. We've got a global setup, which does the setup of our stream. And this benchmark runner is running the whole thing. And then over here, we have our tests now that basically call into our benchmark code and just validate that it does what we think it does in terms of we are getting a cluster health response back with the right properties from the JSON serialized to the right properties of our actual class. So that's all kind of, we're kind of testing library code at the moment. This is library code we don't own that does this, but we are also testing, have we set up the stream correctly? As we saw earlier, did we have the right attributes on things so that the serialization and deserialization could work? So we've kind of done all of that proof now. So in the next stream, we will look at writing a custom reader and take this a bit further. And basically we'll see if we can improve on any of these and any of this kind of stuff. This is our benchmark for results if you've just joined as well. So we've run our benchmarks. These are our execution time, mean execution time for each of these, and then the bytes allocated. And the clear thing is Newtonsoft JSON, while a great library, is not super efficient in terms of allocations. 6K of allocations for that one type is quite heavy. Using Utf-8 Jason, we've got better. System Text JSON even better, but the times are different. So we've got a choice to make between those 2 serializers at the moment. So let's check what we've got left here. So I've got all my types here. So I'm just going to add everything. Let's add everything and just do a commit on this, which is added initial benchmarks and tests. That'll do. I'll probably off stream because it's not that exciting. Set up a GitHub repo, and let's do it now. I've got I've got enough time. I probably can still make my my supermarket shop. So actually, I'm going to do this in Chrome because that's already pre-authenticated. Just going to make sure I don't reveal any secrets. So it's just sort of round us off nicely, and it's probably, you know, it's good practice to get into. Actually, you know, putting your stuff in source control. What is our project called here? JSON benchmarks. So we'll probably call this the same. I haven't already used that, which is good. We'll make this public. We'll add licenses and readmes another time. For the time being, I think we can all assume it's public code. So I've already done my commits. I'm going to just set up my remote now. I'm going to set up my remote. And we'll push our main branch to origin. So if I'd put this off till another time, I would have forgotten to do it. So now we have the code. So that's up online. I'll paste that into the chat if anyone wants to poke around what we've got so far. And that, I think, is where I'm going to leave it today. So looks like we've got 17 viewers, which is pretty cool. Thank you for sticking with me. There was some less exciting stuff, I think, in there in terms of copying and pasting attributes onto JSON. You know, the intent, as I say, is to continue this, and I think, you know, the next stream will probably be a lot more interesting for those that are keen to see. Like, I suspect we'll work with array pools because we'll be reading from the stream in an efficient way. We'll be working with the Utf-8 Jason reader, which is the kind of efficient type that should give us zero allocation reading. And then we'll try and figure out like how we want to write our code to take a known schema for the JSON and convert it into our type, and see if we can kind of get faster and better. So as I say, thanks for joining me. Thanks for sticking with the sound issues I had at the start, which turned out to be my laptop that I was testing it on. So I must make sure the test machine works. And I will find a slot hopefully for this week when we can continue. So just keep an eye on me on Twitter at Steve J Gordon. I'll tweet that out with as much notice as I can. I'll aim for a similar time. This is kind of good for me. It's the end of my work day. So I'm not sort of losing too much time from my work day, but and hopefully most people are able to jump on as well. So with that, thank you, and I'll see you all next time.